All right, so now we will be doing, let me fix the mic, put this up. Okay. It's not the best, but okay. Second problem that we're going to do, the study plan is problem 35, search insert position. So given a sorted array of distinct integers and a target value, return the index where the target is found. If not, return the index where it would be if it were inserted in order. Let's write the algorithm with O log of n runtime complexity. Okay, so basically another binary search with just a little twist. Basically, if it's not found, instead of returning -1, we want to return where that target would be. So for this example here, and the output would be 4 in this case. Let's space this out at the indexes for you guys. Okay, so here we know our left pointer would be here. Our right pointer is here. If you don't know how to do binary search, watch the first video. I kind of explained it, or many videos on YouTube explaining how it works. Our mid pointer is 3 minus 0 divided by 2. It's 1.5 plus 0, so it'd be 1. So we know that 7 would actually be put here, right? 7 would be put in this situation, in this area. Okay, so the method that I thought that works, we can still use binary search, is basically go through this, and when our while loop breaks, right? Remember, our while loop is while our left pointer is less than or equal to our right pointer. So binary search here says that 3 is less than our target, so we update left pointer to be here, and our new mid is now going to be 3 minus 2 is 1 divided by 2 is 0. No, 3 minus 2 is 1 divided by 2 is 0.5 plus 2 is 2.5. Truncate off the decimal, so our mid pointer is here. Mid pointer, left pointer at the same spot. Mid is still less than our target, so update the left pointer to be left plus 1. Mid plus 1. So now left and right are the same. We're still in our while loop because left is now equal to right, and we're in the loop until while less is less than or equal to right. While left is less than or equal to right is when we're in this loop. So mid is less than our target. Oh, let's find the new mid here. We didn't find the new mid there. So new mid of this, 3 minus 3 is 0 divided by 2 is 0 plus 3 is 3. So we're all at the same spot now. 6 is still less than our target, so update our left pointer once again, right? Left is mid plus 1. So now left, our right is at 3, and our left is here. Our left is in this spot where there would be a 4th element in the array. This breaks the loop because now left is greater than right, but our value, we still have this value here. We still have the value 4. We return that. Okay, that checks out. Let's do it with this one. Let's say we're doing a different one. Let's say we're doing here, where our target is 2. Our output should be 1. Our output should be this spot, right? So same thing. Let's set up our pointers. We have our left pointer here, our right pointer there, and our mid pointer is going to be 3 minus 0 is 3 divided by 2, 1.5 plus 0, 1.5 integer division says that our mid pointer is here. 3 is greater than our target, so we update the right pointer. Right is mid minus 1, so we're here. These are our pointers now. Left is still less than or equal to right. Update the new mid. Our mid is going to be 0 minus 0, 0 divided by 2 is 0, plus 0 is 0. Our mid is here. They're all at the same spot. 1 is less than our target of 2. Or if we're less than our target, we update the left pointer to be mid plus 1. Okay. Left pointer is now here. Pointing at index 1. Our value is 1 for our left pointer. But we break out of the loop. Why? Because left is now greater than right. We break out of the loop. And instead of returning -1, again, we'll return our left pointer, which holds the value 1. So this checks out. Right? So basically, we just do binary search, instead of return -1, we return left pointer. Very easy approach. Took me a while to understand, but I hope you guys get it. So let's basic binary search, create a left pointer, right? Create a right pointer, which is equal to nums.size -1, while our left is less than or equal to right. We get our mid pointer here, and be very careful of integer overflow. Overflow. We do right minus left. Actually, I read that person that created the binary search actually had it. They actually had it as right minus left divided by 2 for over, I think, 2 decades, they said, until they came across some overflow error. I know Python you could do it like this, but anything else, usually you have to check for overflow. So that's why we updated to left plus right. We do left plus right minus left divided by 2. Okay. So if nums of mid is equal to our target, well, we return that mid value. Else if nums of mid is actually less than our target, well, we know that we update the left pointer. 3 mid plus 1. Else, it's just remember basic binary search, meaning that our mid value is actually greater than our target, and we have to take everything out from the right side. So right is equal to mid minus 1. And once we break out this loop, we know that our value at the left is going to be where we need to insert this position. And we will erase this for now. Run this code. This works. Submit it. And we're good. So I did some testing here. Make sure I was good for the video. Everything works. Check the details. Passed all 64 test cases. 8 milliseconds. Not too bad. Well, definitely is a faster way. Always a faster way. But yeah, that's pretty much it. Hope you guys enjoyed that video and stay tuned for the next one. Peace.